In this video, we're going to evaluate a very straightforward integral using a U-substitution. This is mainly for those that haven't had much experience with U-substitution. So I'm going to do this just to make a point. So in this problem here, the C, the A, B, and C are constants. And we're going to use a general U substitution here. I'm going to let U equal to the denominator, AX plus B. Then we take the derivative of both sides. So the left side will give me a du. The derivative of constant B is 0. And then A is multiplied by variable. So here we have a 1 times A is A. Subtract 1 from the 1, you get x to the 0. So you just get 1, or 1 times A is A. And this will be a dx. And then we want to transform this integral into one involving u. So I'm just write this as the integral of, and here I'm going to replace the dx. I'm going to divide here by a and a. So this cancels out. So the dx right here can be replaced by du over a. I'm going to put the 1 over a out in front. A is a constant, so is 1 over a. So I can bring it outside the integral now. And then this will stay a c, and then this will be du. And the ax plus b, that's your u. Now I could bring the c out in front also, and write this as c over a, and this will be the integral of du over u. And that's one of your formulas for computing antiderivatives or integrals. Anytime you have anything that has this format, du over u, where u is a function of x, the integral is ln, natural log, of absolute u plus a constant of integration. And then this would be c over u, or c over a. And then we go back, always go back to the original variable. This will be c over a, natural log of absolute u, but u is ax plus b. And I got the constant of integration, and this would be your answer. So the point being here then is this. Okay, you have a constant there. Let's suppose a is equal to 1. If a is equal to 1, then the coefficient here in the answer is c over 1, and that's just c. And in the absolute values, a is 1, so this would just be x plus b. So anytime you have the integral, say any number you want, I'm going to call it just c. Let's see, c can be 1, 3, -5, whatever. And then this is dx. And let's say in the denominator you have x plus any number. Let's just call it b. And then the only difference here is that the coefficient of x is 1. Anytime you have anything like this, you don't have to use a U substitution. You can just say, go directly from here and say, okay, we got 1 over, if this is a 1, it's always going to be the natural log of absolute x plus b. And then the coefficient here is going to be whatever constant you have in the numerator. In this case, it's c. And then the constant of integration, since I have a c there already, I'm going to put a c1 here. And I guess the same thing on this one over here. Because I have a c here, but I would put a c1 here. Or k, something else, to represent your constant of integration. So we have this situation. So let's just look, and again, it has to be this format. Now you've got an x over here multiplying the c. That's a little bit different than what we're doing here. So just to give some examples of this, let's just put numbers in there. Let's suppose we have 3 over x plus 7 dx. Again, as long as the coefficient of the x term in the denominator is 1, then you can just say it's going to be the natural log of whatever you have in the denominator, as long as it's first degree and there's a constant on top. Absolute x plus 7 plus some constant of integration Whatever number this is, just multiplies this. That's your answer. Or let's just say 1 over x. Don't need a U-substitution. You can just go directly. If it's in that format, it's just ln absolute, whatever's in the denominator. In this case, it's x. Coefficient here is 1, so I just leave it out. Plus the constant of integration. That's your answer. Now again, this is say something different here. The coefficient of x is 2. Then you're going to have that factor over here for this one here. This would have been a 2x plus 7. And you have your 2 here, like I did in the other one. Now you've got the integral of, say, x over x squared. Now you've got something like this, the integral of x over x squared plus 1, where you can still let this equal to u, and then the du would be 2x dx, and that works fine because you have the x here. That's different than when you have a constant over here. And I've done plenty of those in other videos. But just thought there'd be somebody there that, again, needs a little bit more work on these very basic types of problems. Thanks for watching. We'll see you next time.